Namaste. My name is Nikhilesh and I try to teach AI and generative AI in a very simple language. So in this video we'll talk about prompt caching. So as the name suggests, it has to do with caching of the prompt, right? And the concept is also very straightforward, like why we do any caching, right? So we all know that prompts are the integral part of any generative AI applications. Now, problem happens when the prompts become too large, and there are two ways in which prompts can become large. One, the prompt itself is very large, or second, we are sending too much additional data, and in that case, the prompt becomes very large. Now, what if we can cache the prompts so that we don't have to incur the same amount of input token price. So if we can cache, then it can read from the cache memory, and we can save on the input tokens, and at the same time we can also make the application faster. We can reduce on the processing time, basically, right? We can have good latency, right? Now, so this is the concept. You can So we have a prompt and we cache that prompt, and next time if we are sending a new prompt, so it will check first from the cache memory, and if there is some additional information, then it will process it from there. So we'll save on these many tokens, right? So let's see how we can do this. We can do this by using Anthropic's feature. So let's install Anthropic. Okay, and we'll be using Anthropic API, and and Anthropic APIs are not free, so you have to incur some cost for running this a notebook. You can go to Anthropic's website, make an account, add you have to, I think, add minimum $5, and then you can start using their APIs. Now, once you have added the API, we are using the model Claude 3.5 Sonnet, which was released on 22nd October 2024. Okay, now I am loading a text file, right? How you can load the text file? I can share this text file. You need to upload it from here, and then once you have uploaded, you can copy the path and you can paste it here, right? Now, once you have pasted here, you can see the length. It has some 8,225 words, which are also not on a lower side. If you want to read the content, you can see from 1,000 to 2,000 words. So here are 1,000 words. So now we have uploaded. Okay. Now let's make an uncached request. Very simple. We are making a call. We are passing the content, and then what we are doing here, we are basically passing the model maximum token. Uh, we are specifying 500, and then we are actually calculating the time. How much time did it take? And it will print the time, and it will also print the response. We are more interested in time. Response could be anything, but now, and you can see it is taking some time to print the output. We are more interested in time, so it took around some 6.42 seconds. Okay, and here this is our interest is the usage. So now if you see, input tokens were 2,110, output tokens were 299, and there were no cache creation input tokens, and there were no cache read input tokens, right? Because we haven't cached anything. Now let's run the cached version. Now for the cached version, this is where the magic is. We are using this cache control feature, and we are specifying type as ephemeral. Now what this feature is doing, basically it is taking the input and it is caching it, and next time when we send another input, it does two things: read and write. It will check whether that thing already exists in the memory or not. If it exists, it will only take that thing which is not there. Basically, it will write only that thing which is not already present. So this is how we'll do it. So it's not that we every time we will we have it will not keep adding the thing. Okay, now what we can do, so first let's make response 1. Now when we are making the response 1, there is no caching that exists, right? So now there is no caching that exists, and if you can see, and now let's see the usage, right? So now what happens here is that we made input tokens. So now 2099 input tokens you know were created. There were no read tokens, and input tokens were reduced to 11, and output tokens were some 326. Now let's make the response 2, and now you can see with this there was no creation of token happened. Everything happened from the read input. So second time when we ran it, the basically we used read input tokens. Input tokens were still 11, and output tokens this time it was 348. So what we are doing here is basically we are making these things. Now let's see the duration. Okay, so duration is more here, but we saved on time. Maybe because the tokens or the input tokens that we were sending were less. But if you send more tokens, like maybe around 1 lakh tokens or maybe more, then this duration also reduces, and you can have, and definitely we are saving on the cost. Now if you see how much cost we incur. So now if you see, for writing tokens, it's 25% more expensive. So there you are incurring more cost. However, you are balancing out with reading tokens. Now once you have written the you have written like the on the in the cache memory, for reading you are incurring 90% less amount. Regular input and output tokens are priced at standard rate, so then there is no difference here. So the point is, you don't have to cache everything. You can only cache where you write it once, and then you are reading it multiple times. So if you have to send same content again and again, then you can read it, and you can write it, and then you can read it as many times you want, and you can save money. uh, so that's how it works. I hope you like the video. If you have any questions, please let me know. Thanks for watching.